All right. Hello, everyone. This is Samantha, your math teacher. This is a little different because instead of in my classroom, I am currently in my home. And since I do not have a 6-foot whiteboard in the middle of my living room, I'm sharing my screen instead. So we'll see how this goes. Thank you for your patience in advance. This video is going to be a review of all the lessons you covered in Unit 1. So just as a quick reminder, those first 3 lessons were equations. We looked at how you solve some crazy looking like multi-step equations and proportions. Then we looked at some equation word problems, and then finally literal equations, so those equations that had multiple variables in it. Then we looked at 3 lessons on inequalities. So we talked about how you solve and graph inequalities, how you solve and graph compound inequalities, which were those problems where you had 2 inequalities at the same time. And then we looked at inequality word problems. So what I have done is I have gone through all the homework that has been turned in so far and pulled out questions based on the homework problems that the most students missed or the most students found challenging. So these aren't identical to homework problems you've done, but they are inspired by homework problems that you all found more challenging. And that deserve being talked through a little more. So one of the things we say in class a lot is mistakes are great when it comes to learning, right? And that's kind of like what this lesson is based on, right? We are about to benefit from mistakes that multiple students made to help everyone learn and understand a little better. So I've talked enough. We'll go ahead and get started. The first thing I wanted to mention with questions that students missed or didn't get full points for was this idea. It may seem simple, it may seem silly for me to say, but this idea that you need to read the directions carefully. Specifically, the 2 things below it, the idea to make sure you answer what the question is asking and make sure that you answer all parts of the question. So that first part, make sure you answer what the question is asking. Sometimes I ask, here is a problem, like explain to me why the next step should be multiplication, or don't answer the question, just tell me, like describe to me what you would need to do to solve the question. And sometimes students just want to give the answer. They don't want to answer the why, they don't want to describe, they just want to say the answer is 4. And make sure you're answering what the question is asking. If I'm asking you to represent something with an equation, or if I'm asking you to identify a mistake a student made, I'm not asking for the answer, I'm asking for something different. And then the second part of that, make sure you answer all parts of the question. I talked about one of the most beloved questions I have is asking you guys why or explain how you know, those type of things. Usually those are a follow-up question. So I might give you a math problem and say, what's the answer? Justify or explain how you got that. There are two parts to the question in that. And a real common reason for a student not to get full points on a homework question is just they're missing one of those 2 things. It's not that they got it wrong. It's just they stopped at the answer and they didn't justify or they didn't explain why. So as you go into our first unit assessment, keep those things really in mind. Make sure you're answering what the question's asking. Make sure you answer all parts of the question. An easy way to make sure you're doing both of those is after you've written your answer, you've chosen your answer, whatever it may be, go back and read through the question just one more time to make sure you are addressing everything you need to address and you're answering everything you need to answer. So this is the first thing on our list. The next one is an actual math problem. This comes from the first part of our unit on solving equations. The question's asking, what is the difference between these 2 equations and how would you solve them? Go ahead and try to answer this question. Notice again, there's two parts to the question here. What is the difference between these 2 equations? That's part 1. And how would you solve them is part 2. All right, so looking at them, visually the difference is on this left side, right? Over here, that division line goes under both x minus 4, and over here, that division line just is under x. So that means the difference in what they're saying is this first equation is saying this entire quantity, x minus 4, we're going to divide all of that by 2. Whereas over here, this is just saying we're only dividing x by 2, and then after that, subtracting 4. So it has the steps in a different order. This is saying first we're going to subtract 4 from x, then divide. This is saying first we're going to divide and then subtract 4. So that idea of what's being divided is what's making these equations different. So as far as what you would do to solve them, since over here everything is divided by 2, the first step you're going to have over here is you need to start by getting rid of that divided by 2. So let's try this here. Their first step here, some students would solve it by cross multiplying. So one way you could do this is come in and say, let's make that side look like a fraction too. That way this entire side is a fraction equals this entire side is a fraction, and then you could cross multiply. That's one way you could do it. Or alternatively, you could just come in and say, to get rid of that fraction, we're going to multiply by 2. It is much harder to write with my finger. Multiply by 2. When you do that, these 2's would cancel out, which would leave you with x minus 4. And then on our other side, we would have 8 times 2, which equals 16. And then from there, you could solve. You could add 4 on both sides, and we would get our answer as x equals 20. Now on the second problem, for the second equation, you could start off, if you wanted, by multiplying by 2 like you did over here. The difference is here, this is all one term. This is all together. Here, this is 2 terms. There's 2 parts to it. So if you did want to multiply by 2, you would have to come in and multiply this term by 2. You would also have to multiply this term by 2. And you would also have to multiply this term by 2. That is one way to solve the second equation. I think we said in that very first lesson, there are lots of different ways to solve equations, believe it or not. So this is one way. If you did that, those 2's would cancel. You would be left with x all by itself, which is why we would be multiplying that 2. But then the 2 times 4 would give you 8. And then on that other side, the 8 times 2 would give you 16. And then when you went to solve that, you would add 8 on both sides, and you would get x equals 24. I promise I'm not going to be writing too much math in this video with my finger. So that's one option. I'm just going to go ahead and erase everything. The other way you could do this is over here, you can't start by adding 4 because that 4 is divided by 2. You would have to get rid of the division first. However, here you could start by getting rid of that minus 4 by adding 4 on both sides. Now when you do that, that would leave you with the x over 2 on that left side. And then on the other side, you would have 8 plus 4, which is 12. And then you could solve this equation. You've got that x divided by 2, so you would want to get rid of the divided by 2 by multiplying by 2, which would give you x equals 24, which also is the same thing we had before. No matter how you solve these equations, a good thing to check is just always taking your answer and putting it back in the problem. So here, the 24, if I put 24 here, 24 divided by 2 is 12. 12 minus 4 gives us 8. Before we had 20, if I put 20 here, I would have to do that subtraction part first. So 20 minus 4 is 16, and then 16 divided by 2 gives you 8. So just as a reminder, that's always a good way to check your answers. Now, also, depending on how you think about solving these equations, your written response to this is going to look different. This is just one example of what you could have written. I have to move my face. How do I move my face? Oh, that's not what we want to do. Okay, let me just make me smaller. Sorry, guys. But it says, the first equation says x minus 4 is divided by 2, while the second equation just says x is divided by 2. This is important because it changes how you would solve them. For the first equation, you would have to cancel it says the 2. You would have to cancel the dividing by 2 first by multiplying both sides by 2, but the second equation, you could add 4 to both sides since the division only applies to x. Like I said, that the second part of how you would solve them is going to look different based on who's writing it, since there are lots of ways to solve them. But I'm really highlighting here the difference between the two of them by saying this first one, the whole thing is divided by 2, the whole amount, x minus 4, is divided by 2. Whereas for the second one, it's just saying x is divided by 2. So this is one example. Moving on, the next one we're going to look at says, find the mistake in the student's work. You guys might have noticed I like questions like these because it really gets behind, it helps me get in your head, right, and see what you're thinking, and oftentimes gets behind the why in math too. So it says, find the mistake in the student's work, explain what they did wrong, and what they should have done instead. So we've got a fun literal equation. Remember, literal equations are these equations that have multiple variables in them. So we've got a literal equation. Because literal equations have multiple variables, these problems are always going to have to tell you what to solve for. You could solve this equation for A, B, C. It's already solved for D, but I mean, you could solve it for D too. But this time it's saying solve for B. So the student who did this work is trying to get B right here all by itself. Let me break out that pen. They're trying to get B all by itself. Starting off, they started by, let's go ahead and have you try figuring this out first, actually, before I tell you the answer. So you're trying to find the mistake in the student's work. And again, there's 2 parts to the question. Part 1 says explain what they did wrong. Part 2, and what they should have done instead. Go ahead and try. All right, let's see how you did. So they're trying to get B by itself. So they started by getting rid of the constant by adding C on both sides. That looks good. So they're left with 2AB equals D plus C. The next thing they did was they subtracted 2A. Now, why are they trying to subtract 2A? Well, they're trying to get the 2A to cancel. And so they're left with D plus C minus 2A. Well, here is where that issue is going to be. Anytime you are trying to solve an equation and cancel something, to cancel something, you're always doing the opposite. So for example, up here, the opposite of minus C is plus C. But down here, we have to ask ourselves, what is between the 2A and the B? You're trying to get rid of 2A, but what type of math is happening between those? Well, 2AB, when you've got everything written next to each other like that, means multiplication. So in order to cancel the 2A, I got to do the opposite, which is division, not subtraction. And this is a very common mistake students make. Students love subtracting what's in front of the variable. But we can't. We can't because this is multiplication. We have to do the opposite, which would be division. So this right here would be the mistake. Now, if I'm trying to explain what they did wrong, if you were to say something like they subtracted 2A instead of dividing. So let me switch back to this. If you were to say something like this, they subtracted 2A on both sides instead of dividing. That's good. You are doing what the question asks. I'll be happy. You get full points. You explained what they did wrong. What they did wrong was they subtracted 2A. And you told me what they should have done instead. They should have divided. So you're getting all those things. The purpose of these questions is to really get behind the why. Do you know why they should divide? So another option, I swear I can move my face, but I don't know how to do it. I guess let's get rid of me. Bye. Another example is here, which says in the student's second step, so this is step 1, step 2, they tried eliminating 2A by the student made a mistake here. It should say by subtracting 2A. This is the mistake they made. 2AB means 2A times B. We need to use the opposite of multiplication, which is division, to get B by itself and cancel 2A. The difference between this one, which is probably the most common response I see, and this one is this one talks about the why. This one just says you need to divide. This one explains why you need to divide, which, especially since you all are at home and I can't just sit next to you constantly asking why. This is really what I'm trying to get at is, do you understand why you need to divide instead of subtract, which this one does a good job at answering. Like I said, these are both good answers. They both would get full points. I just want to show you, because I've had some students ask, like, I don't know if I'm doing these written ones right. I just want to show you like an answer that would just make me go, oh, look at this. This was such a great response, Denise. This is where we're setting the bar at, right? We really want to see answers like this. Moving us along, let me come back. Hi. And let's erase this. Our next one comes from the second lesson we had on inequalities. This one says, what is the difference between the following? And we've got two inequality problems here. Part of the reason I've got this question here is just because a common mistake I saw is students mixing up the less than and greater than signs. If it looks like this is a less than sign. The way I learned it is the less than sign looks kind of like the letter L. So you can think like L for less, and then the sign, it's kind of just like a sideways L. I know some students also use their arms. So if I don't know what it's going to look like for you, but this is my left arm, and I can make it look like that sign. So left arm for less, the right's just the other one in both of these scenarios. So find the way that works for you. But multiple students missed questions because they had those inequality signs backwards. So make sure you do whatever you need to do to keep track of which one's which, because that's going to be really important to understanding these problems. So this one over here is telling us x is less than 3 or 5 is less than x. And then this other one, we've got 3 is less than x, which is less than 5. Again, I'm going to have you go ahead and try answering this question. What is the difference between the following? All right. One thing I would do before I answer this question is we had talked about in, I think, all 3 of our inequality lessons that it's easier for a lot of students to have that variable on the left side when you're thinking about what these things are saying. So for this 5 is less than x, something I would do to help me out, to help students out, is I would just flip this around. Instead of saying 5 is less than x, if you read it backwards, it says x is, oh, come on, greater than 5. So we've got x is less than 3 or x is greater than 5. Well, what is that saying? It's saying there's 2 possibilities for x. X could be less than 3, so that's 2, 1, 0, all those negative numbers. Or x could be greater than 5. What numbers are greater than 5? Well, 6, 7, 8, 9, 100, 1,000, tons of numbers. So when we looked at those graphs, what this is saying is there's 2 different groups of numbers x can be. X can be, I'll put 0 in the middle, just because that's a point of reference. We've got x is less than 3. Well, 3 would be over here. Numbers that are less than 3 would not be 3, so I'm using an open circle, but all of these numbers in this direction are less than 3. So x could be all of these numbers, or x could be greater than 5. Well, 5 would be here. I'm also using an open then circle because x can't equal 5. It's just greater than 5, which would be all the numbers in this direction. So we end up seeing x could be like 2 possible groups of numbers. These numbers less than 3 or these numbers greater than 5. Now this one looks similar, but it says something very different. I originally read it 3 is less than x, which is less than 5. If you broke it up into like 2 statements like this one, you've got x is, you got to read it backwards, kind of like this one here. X is greater than 3 and x is less than 5. I think the easiest way to at least say it to yourself when you see things like this is this idea of using the word in between. See how x is physically in between those numbers? This is saying x is in between 3 and 5. Well, what does it mean to be in between 3 and 5? It's like the middle group of numbers, right? 4 is the first number that comes to mind, but we know you could also have decimals and fractions. You could have 3.1, you could have 4.9. It's all those numbers in between 3 and 5. So when you think about it on a number line, again, you just lots of times C0, there's kind of a point of reference of where you're at on this line. But we've got 3. We've got, ooh, that's a weird looking 3. We've got 5. That one's not much better. We're trying to say X can be all of these numbers in between. So just like that other one, I'm still using open then circles. I'm still using open circles. But instead of going in these opposite directions, we're saying X is all of these numbers in between. These, especially if it's your first time seeing it, or if it's just been a really long time since you've seen these compound inequalities, these two things are easy for students to mix up. In general, or inequalities are talking about two different groups. So they're going to be arrows going in opposite directions. We're talking about these numbers or these numbers. These and inequalities, which can be tricky because they don't actually say the word and in them, but instead it's one inequality. See how it's written all together? It's one inequality with two inequality signs. This is saying that X is in between these numbers. So you get something like this line segment here. So as far as like options for the answer to this question, one option could be, oh, time to say bye again. One option could be this answer right here. We've got the first compound inequality, this one here, is an or inequality. This means that X can be a number less than 3 or X can be a number greater than 5. If we graphed it, the number line would show two different groups of numbers. The second compound inequality is an and inequality. It means X is greater than 3 and less than 5, or X is between 3 and 5. If we graphed that inequality, the number line would be shaded between 3 and 5, showing X can be any of those numbers. Obviously, I'm a math teacher. Obviously, my answer is long because I'm just hitting everything I could possibly hit when I'm talking about this problem. But again, just to give you an idea of what like a stellar response would look like is something like this. Hopefully that helps a little bit. There is one last problem we're going to look at in this review video. In this last one, we've got Erica and Susanna decide to race. Erica starts 200 feet in front of Susanna and can run 5 feet a second. Susanna, however, is very speedy and can run 10 feet a second. How long is it until Susanna passes Erica? Just like we did with a lot of these word problems, there is a way before you answer the question to represent it using math. And I'm going to give you a clue. This one we're going to be representing with an inequality. Representing it with an inequality is going to help us answer that question. How long is it until Susanna passes Erica? So I'm going to actually break this question into two parts. I'm going to have you go ahead, try representing this with an inequality. All right. So in order to write our inequality, we've got to think about what this means here. Another way to say Susanna passes Erica, what does that mean if Susanna passes Erica? Well, it means that Susanna's distance she's moved is greater than Erica's distance, right? Susanna is further ahead than Erica. It means, I'm going to abbreviate Susanna with an S. It means Susanna, we want her to be further ahead. We want Susanna, her distance to be greater than Erica's distance. There was an example in that inequality word problem lesson where just by writing this down, I think it's helpful to give you an idea of where to place all of your numbers. Because I can see 200, 5, 10, but I think writing this first is just like a quick little middle step before you writing your inequality can help make sure you've got all your numbers in the right place and your inequality facing the right direction. Once I've got Susanna, we want Susanna's distance to be greater than Erica's distance. Now we can start filling in some of our numbers. Well, what do I know about Susanna's distance? I know she is moving 10 feet a second. What we don't know, we know how far she can run in a second, but we don't know how many seconds she's been running, right? That question's asking how long. What we're going to be trying to find is how many seconds. So for Susanna, I'm just going to go ahead and say, well, her distance is going to equal 10 feet times the number of seconds she's run. So 10 times S. By the way, if you ever wondered why I film myself standing at the board instead of screen recording like all the other teachers, this is why. So we've got 10s is going to represent how far Susanna's run. So we want 10s to be greater than Erica's distance. Well, what do we know about Erica's distance? We know Erica is running 5 feet a second. Well, that's real similar to what we just wrote for Susanna, right? It's going to be Erica is moving, 5 feet times the number of seconds she's run, right? That's going to be how far she's moved. But there's something else they told us about Erica. They told us that she started 200 feet in front of Susanna. So Susanna didn't have a head start. Her distance is just solely equal to 10 feet times how many seconds she's run. But Erica's got an extra 200 feet that she's ahead. So she's moving 5 feet a second. But we also need to add in that head start of 200. There we go, 200 feet. This right here is that inequality that represents this situation here. Once you've got the inequality, it helps you answer this question because it's no longer a guessing game, right? It's no longer me being like, well, how far are both of them after 5 seconds? How far are they both after 10 seconds? And just guessing a bunch of numbers till I stumble upon the right answer. Being able to represent this with an inequality means once we've got this inequality, all it's a matter of us doing now is solving it to figure out the answer to this question. So here's my second part. I said I was breaking this problem into 2 parts. We've got our inequality now. Now go ahead and try answering this question. How long is it until Susanna passes Erica? And go. All right. Well, if we want to solve this inequality, since the number's on this side, I'm going to bring s, our variable, to this side by subtracting 5s on both sides. I'm not going to write that down. I'm just going to write what we get when we do that. If you subtract s on both sides, that would cancel the 5s. And subtracting 5s from 10s is going to leave you with 5s is greater than 200. And then you would divide both sides by 5. That's going to give you s is greater than 200 divided by 5. Well, I know 20 divided by 5 is 4. We aren't dividing by 20. We're not dividing 20. We're dividing by 200. So that means this 0 here comes down. And I get s is greater than 40. Now, I know up here I used s as like a brief abbreviation for Susanna's name. But what did this s mean, the actual s in our inequality? Well, 10s, s was how many seconds she was running. So when we say s is greater than 40, we're saying the number of seconds needs to be greater than 40. So the question is, how long is it until Susanna passes Erica? Well, notice we've got the greater than sign and not greater than or equal to. We want to say after 40 seconds, Susanna would be in the lead. Susanna's past Erica. So something like after 40 seconds. The reason we can't say 40 seconds at 40 seconds or how long is it? We don't want to say equal to 40 seconds. One is because this isn't an or equal to sign, but we could always go back and do the math, right? At 40 seconds, at that split second of 40 seconds, where is everyone at? Well, we know that Susanna is running 10 feet a second. So at 40 seconds, she's ran 10 feet times those 40 seconds. When you do that math, that means 10 times 40 is 400. It means she is 400 feet forward. Oh my gosh. Okay. Well, what about Erica? Erica started 200 feet in front, and she's running 5 feet a second. I can't write it down, guys. We do 5 feet a second. Well, 5 feet times 40 seconds is 200. 200 plus 200 is 400. At exactly 40 seconds, they will be at the same spot. The question's asking how long until she passes Erica. She hasn't passed her yet. They're at exact the same spot. But right after 40 seconds, right? 40.1 seconds. That's when Susanna's taking the lead because she's actually running faster. Those first 40 seconds, she was catching up. And then after 40 seconds, that's when she's taken the lead and she's ahead. So to answer this question, you want to be specific. You could say more than 40 seconds or something like that. I think the most natural way to say it, though, is just after 40 seconds, Susanna would be in the lead. Something like that. This is the last example I had. Hopefully you found this video helpful. I recommend before going into the Unit 1 assessment, which will be posted on Tuesday, make sure you have gone through every lesson. So there was 6 lessons in Unit 1. Make sure you've watched all the videos. This will be the last video posted for Unit 1. Make sure you've gone through all the homework assignments. Make sure you've looked at the feedback for all of the homework assignments. I've posted a video sometime last week that showed how you go in and see all the feedback on the Edpuzzle answers you write, on your Google Form assignments you do. Make sure you know how to see all that feedback and you've gone in and looked at all that feedback before you do the Unit 1 assessment. And please reach out to us too if you've got any questions before the Unit 1 assessment. But this was the review video for it. So hopefully you found it helpful. I will be back in front of my whiteboard in my classroom starting in Unit 2. But until then, see ya. Bye.